So notes today is not really notes. We're just going to work some together off of worksheet 3. And so it's just more practice, just kind of mixed up practice, making sure you recognize power rule, trig rules, and exponentials. So to start with, why don't you try 1 and 3 and 5? And I guess I would say 1 and 5 have a little bit of algebra to do first. Number 3 is pretty straightforward. So if you're stuck, maybe start with number 3. That's the easiest of the 3. And then number 1 is probably the next easiest, and then number 5 is the worst of those 3. So try 1, 3, and 5, and then we'll go over those. Addie, how about number 1? You can just tell me the answer. D. Looking at some of those pieces, A, and I guess A happens if you try to do it without foiling it, but there's a chain rule thing going on if you try to do A, and there is no chain rule for antiderivatives, so can't do that. B happens if you square the pieces, but you can't just square the pieces, so that doesn't work. Foil it out and then apply the power rule, and most of you had D. Leo, how about number 3? Yes, E. That's straightforward. There's nothing to do other than increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Yep. Ian, number 5 had a little algebra to do first. What do you end up with as the answer? D. Do we need to see that one? Yes? Okay. So first thing, we never like square roots because we don't deal with those. We want powers. So I'm going to rewrite that as x to the 1/2. And just as a preference, I don't know, I think it's easier to see it when it's in front rather than behind. It doesn't matter, but just, I don't know, personally prefer it there. Then let's distribute. When we're multiplying with powers, we add the exponents. So everybody can do x squared plus x cubed, and yet somehow x to the 1/2 times x throws people off. Calculus is easy. Fractions are hard, maybe. 1/2 plus 1 is 3/2 minus x to the 1/2. And then be careful. I don't think this was an answer choice, but that's a common mistake because people, they get so worked up and maybe so satisfied that they did the algebra right that they forget to actually do the calculus part of the problem. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Don't forget the plus c, although it's kind of already there, so, or at least it's on all the answer choices. So 135 DED. Looking good. Let's turn the page. 2, 4, and 6 are pretty similar. Some of you did those already after you finished 135. This time, let's look at 8, 10, 12. Let's look at the even ones on this page. Let me start you on number 8. Again, it's algebra first, and again, we don't like square roots because we really can't antiderivative them. So let's replace the square root of x with x to the 1/2. What would you do next? What algebra step would you do next? What's that? Okay, and when you multiply x times x to the 1/2, what do you get? X to the 3/2. And then that's still not, I mean, it's not wrong, it's just not ready to take an antiderivative. What do you want to do next? Good, move it to the top by changing its sign. Alright, 8, 10, and 12 are kind of similar, so try those and then we'll see how we're looking. Back up just a second here. So number 8 is A, 10 is C, 12 is E, but we're working on getting there. So I'm going to FOIL that. It looked like most of you knew that this was minus 2 square root of x, which is good. You're not writing out all the terms of FOIL. You can do a little bit of work in your head. And then plus 1, all over. At some point I got to change this to a power, so I'll go ahead and change it. So x minus 2x to the 1/2 plus 1 over x to the 1/2. And I should be careful because I think this is how people forget to do the calculus, is because they drop the calculus symbol and they think, well, I'll just come back and grab that later, and then later never happens and they just do the algebra. So let's not forget that we still need to integrate. Let's see, x to the first over x to the 1/2 would be x to the 1/2, because 1 minus 1/2. Middle term is easy because they just cancel. And then the last term would be x to the negative 1/2. Okay, if you make it that far, your algebra is good. Now I need to worry about calculus. Increase the power by 1, divide by 3/2. Antiderivative of negative 2 is minus 2x. And then increase the power by 1, divide by 1/2. Don't forget the plus c. And so yes, that last sign there was wrong. So I deserve the stamp for messing up that last sign on number 12. Haven't done any trig today. So why don't you try 13 and 14? I feel like 13's easier than 14, but they both involve some trig substitution things, some trig rules to get it into an answer that you recognize. So try 13 and 14. These, and then we'll be done. 1 over sine squared. Okay, I can't do anything with that, but you recognize that sine in the bottom is the same thing as cosecant in the top. And then hopefully, sort of as you're doing that, you're like, wait a minute, I know that one. Like, there is a trig function whose derivative is cosecant squared. It's cotangent, but it needs to be negative. So negative cotangent x plus c. On 14, many of you did what I did to start this problem, and that is your brain thinks, okay, tangent is sine over cosine, so let's start down this path and see what happens. And then the algebra would end up putting both cosines in the bottom. And so this statement is true, but it's not helpful yet. That doesn't get me anywhere. Because that doesn't help. So let's back up and try again. And instead of replacing tangent with something, let's replace cosine with something. And if I want to flip the cosine, that's secant. And then hopefully you know your rules well enough that as soon as you see that, you're like, oh, that's one of the rules. At least you say, I recognize that. Now let me think back in my brain and figure out which one that is. Derivative of sine is cosine. Derivative of tangent is secant squared. And derivative of secant is secant tangent. So the antiderivative of secant tangent is secant of x plus c. And as you may have overheard me telling a few people, the further we go in antiderivatives, the more often this happens. And this meaning you take a path and you don't do anything wrong, you just eventually realize I'm not getting anywhere, and so you have to start over and try a different path. And that's kind of an annoying thing about taking antiderivatives, is like, how do I know which path to take? And the answer is you don't until you've done it a million times, and then you start to realize which path you should take a little earlier. But as you're starting out, you don't know which way to go until you pick one, and if you end up spinning your wheels, well, don't get bogged down. Try to start over with a different approach. Ravia?
You just flip the cosine up?
Mm-hmm. Because cosine and secant are reciprocal partners, and so you can flip them around as needed. All right, I think the rest are pretty straightforward. So your assignment is the rest of the worksheet. Many of you have been working through it as we've gone, so hopefully you don't have much homework tonight. But that'll be it for what we're doing